Good evening, children.
Good evening,
Good
ma'am.
evening. Good evening.
Good evening.
Good evening. So I've shared my screen. Is it visible to all of you?
Yes, ma'am.
Yes, miss.
Yes,
Very
ma'am.
good. Very good. All right.
Yes, ma'am.
Very good. Okay. So to begin with, let's understand how to find the value of a polynomial. See the questions here. If p of x is equal to 3x squared minus 5x plus 6, find p of 2. So the question is to find the value of this polynomial p of x when x takes the value 2. For different values of x, the polynomial will assume different values, different numerical values. For different numerical values of x, the polynomial will assume different values. So when x is 2, what is the value of the polynomial is what we have to find. That's the question here. If p of x is equal to 3x squared minus 5x plus 6, this is the polynomial. It's called p of x. We have understood that here the letter in the bracket represents the variable involved in the polynomial. X, because x is the variable involved in the polynomial. And this can be any small letter other than x. So this is how we name a polynomial. This is how we name a polynomial. This one is the variable involved in the polynomial, and this can be any small letter from A to Z other than this variable. So we cannot say x of x. Okay. Yeah. So how do we find the value? Okay. So p of x is given. P of x is equal to 3x squared minus 5x plus 6. We'll have to find p of 2.
Ma'am,
Yeah.
first one answer is 8 plus 8.
Okay. So p of 2. So 3 into x is 2, right? 2 squared minus wherever there is x, replace 2 plus 6. So p of 2 is equal to 2 squared is 4. 2 squared is 4. 4 3s are 12. Okay. Minus 10 plus 6. So 12 minus 10, 2. 2 plus 6, 8. Good. Correct. But who's this in the name Satya Parkavi? I don't know the student's name. Maybe your parents' name there. So who's this? Okay. Next time, we join an online meeting, please make sure you join with your name. Okay. Please join with your name so that I can identify you. See, now I don't know. There are a few who have joined with a different name, so I'm not able to identify who you are. So P of 2 is equal to 8. So the value of the polynomial when x is equal to 2 is 8. Yeah, take down. Please take the question and work the answer. Please write down the first question and complete the answer. Similarly with the second and third one. Second question, second answer, third question, third answer. Complete it. What's the answer for the second one? Okay. So 2 root 2 into 2 root 2. 2 into 2, 4. Root 2 into root 2 is 2. So 4 into 2, 8. 2 root 2 into 2 root 2. 2 into 2, 4. Root 2 into root 2 is 2 and 4 2s are 8. Minus, same thing here. 2 root 2 into 2 root 2. 8 plus 1. So the answer is 1. Q of 2 root 2 is 1. Finished?
Yes, miss.
Very good. Complete the third one. So in the third one, when you substitute minus 1 for x, see how to simplify this one. Minus 4 into minus 1 the whole square. You need to simplify this first. You should not multiply minus 4 and minus 1. You must first simplify the power. Minus 1 the whole squared. So minus 1 into minus 1 is plus 1. So it is minus 4 into 1. And now multiply. Minus 4 into 1 is minus 4. In the third one, minus 4 into minus 1 the whole squared. You should not multiply minus into minus plus 4 into 1, 4. It's not like that. You need to simplify the power first. Minus 1 the whole squared is minus 1 into minus 1, which is plus 1. And now minus 4 into 1, which is minus 4. So this is how we find the value of a polynomial at a given value for the variable x, y, or z, whatever is the variable. A value will be given for the variable, and this is how we find the value of the polynomial for the given value of the variable. Done, children, all of you? All of you must be writing, not just listening to me. I'm giving you time to write.
Finished, miss.
Yeah.
I need some time.
Okay, okay. Yeah, Chalu. Done, all of you?
Yes, ma'am.
Yes, ma'am.
All right. All right. See this question. Find the value of A for which x minus 1 is a factor of p of x equals a square x cubed minus 4ax plus 4a minus 1. Let's understand the polynomial. So the polynomial is called p of x, where x is the variable, and the polynomial is a cubic polynomial. You can see here x cubed. This is the coefficient of x cubed, a square. All right. So this is a polynomial in one variable x because you can see p of x here. The variable is mentioned in the bracket here. A is not the variable. A is not the variable involved in the polynomial. X is the variable. X is the variable. You can see it in the bracket here. P of x. X is the variable. And what is the highest power of x you see here? X to the power 3. The highest power is 3. Here, x is raised to the power 1. So the highest power is 3. So the given polynomial is a cubic polynomial. What else is given? X minus 1 is a factor of this cubic polynomial is given to us. X minus 1 is a factor of this cubic polynomial given to us. So with this information, we need to find the value of A. We can see A here, A here, A here. You need to find the value of A. So we are given a cubic polynomial, one of whose factors is x minus 1. We know a cubic polynomial can have a maximum of 3 factors. A cubic polynomial can have a maximum of 3 factors. One of the 3 factors is given to you. With the help of this, you need to find the value of A. So to work this, you need to equate the factor to 0. See here. So this is given to us. X minus 1 is a factor of P of x, right? So equate the factor to 0. X minus 1 is equal to 0. So on solving this, what do you get? X is equal to 1. Now, what do you think will be the remainder when you divide a polynomial with its factor? The remainder is 0. Whenever you divide a polynomial by its factor, the remainder has to be 0, right? When you divide 28 by its factor 7, so 7 fours are 28. Remainder 0. So the remainder on division will be 0 because you're dividing the polynomial by its factor. So the remainder is 0. Now, how do you express that as an equation? So when we say the remainder is 0, that means the value of the polynomial at x is equal to 1 is 0. See, this place is reserved for the remainder. I'll tell you when you should have understood. Now you're just hearing something. It's not clear. Okay. So let me finish and then when I ask you, you should have understood. So don't worry now. I'll just come again. We are given a cubic polynomial and one of its factors. We know that when we divide a polynomial by its factor, the remainder will be 0. All right. Now, how do you express this information in an equation? The value of the polynomial at x is equal to 1 is 0. Why 0? 0 because the remainder, when you find the value of the polynomial, because x minus 1 is a factor. X minus 1 is a factor and the value of x is 1. Now, when you find the value of the polynomial at x is equal to 1, the remainder will be 0. If it's not a factor, the remainder will not be 0. Then the remainder will be given to you. If it is a factor, a remainder need not be given because you know the remainder will be 0. If it's not a factor, the remainder will not be 0. The remainder will be given to you. If it's not a factor, remainder will be given to you. If it is a factor, you know the remainder will be 0. So here it's a factor. So we know the remainder is 0. For what value of x? When x is 1. So I'll write it here. The value of p of x at x is equal to 1 is 0. 0 because remainder is 0. Why remainder is 0? Because it's the factor. Now, how do you express this as an equation? How do you find the value of p of x at x is equal to 1? That's represented like this, p of 1. When you write p of 1, because the polynomial is p of x. The polynomial is p of x. So when you write p of 1, that means you are finding the value of the polynomial at x is equal to 1. And the value of p of 1 will be 0. Why? Because x minus 1 is a factor. So here you should write the remainder. P of 1 is the value of the polynomial at x is equal to 1. Is equal to what you should write here is the remainder. And here we know the remainder is 0. If it is not 0, it will be given, the remainder will be given to you. You should write that here. This place is reserved for the remainder. The value of the polynomial p of x. The value of the polynomial p of x at x is equal to 1 is the remainder 0. P of 1, p of x is the polynomial. P of 1 means you're finding the value of the polynomial at x is equal to 1. Now you know what the answer will be. The answer is the remainder always. The answer will be the remainder. And what's the remainder here? 0. Because x minus 1 is a factor. If x minus 1 was not a factor, then there will be some remainder, but that we will not know. If the remainder is not 0, you cannot guess the remainder. Then the remainder will be given to you. So you should write that remainder here. So now here we know the remainder is 0. So the equation is p of 1 is equal to 0. P of 1 is equal to 0. So we'll just do 2-3 sums. At the end of that, I'll ask you. If you have any doubt, you can get them clarified. Okay. So this means p of 1 is equal to 0. So how do you work p of 1? In the polynomial p of x, wherever there is x, you should use 1. Only where there is x, not a. Wherever you find the variable x, there you should use 1. Okay. So see here. So p of 1 will be, p of 1, you should write it here. P of 1 is equal to a square into 1 cubed minus 4 into a into 1 plus 4a minus 1. Okay. In place of x, use 1. So p of 1 is what? See, you should write this equation. Once you write this equation, everything becomes easy. You must know to write this equation. Once you write this, how do you express p of 1? This is how we express p of 1. In the polynomial p of x, wherever there is x, write 1. So a square into 1 cube minus 4a into 1 plus 4a minus 1 is equal to 0. See, this is equal to and 0. Is equal to 0 is from here. Is equal to 0 is from here. This p of 1, we have expanded on that. We have worked p of 1 here. Now simplify this. So you get a square minus 4a plus 4a minus 1 is 0. Minus 4a plus 4a gets cancelled. So a square is equal to 1. When you transpose, a square is equal to 1. So a is equal to plus or minus 1. Plus or minus square root of 1, which is plus or minus 1. Work this, children. If this is somewhat understood, like 40 to 50%, good. Second, third sum, by the end of the third answer, I think it will be clear. Let me check. Yeah, please finish writing this. I'm right here. I'll just turn off my video for some time. I'm right here. Please complete the answer and let me know.
I'm completed.
Finish writing, children? All of you?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay, so I can see Anika, Gayatri, Haridarshan, Harsha, Lakshana, Nuved, Yarni. So Tanuja, students in the name Tanuja and Satya Parkavi should, help me identify you both. And Surya is there.
Parkavi is Rahul.
Rahul. Okay, Rahul. And Tanuja? Sanjay. All right. Yeah. All right. Done, children? Okay. Look at this question. If x cubed plus mx squared minus x plus 6 has x minus 2 as a factor. So again, this is a cubic polynomial because you can see the highest power of x is 3. It's a cubic polynomial. And it's given that x minus 2, a cubic polynomial has a maximum of 3 zeros. And one of the, a cubic polynomial has a maximum of 3 factors. And one of the factors is given to you here. X minus 2 is a factor. And leaves remainder r when divided by x minus 3. So when you divide this polynomial, this cubic polynomial by x minus 3, the remainder is r. Given this information, you need to find the values of m and r. See, understanding the question is very important to work the answer with ease. So let's spend some time to understand the question. This one is a cubic polynomial. The name is not given, so you can give it a name. See, sometimes in the question it's given it's p of x or f of x. If nothing is given, you can name the polynomial in your answer. So this is a cubic polynomial. As we understood, the highest power of x is 3. So it's a cubic polynomial. Now there are two more polynomials given to you, x minus 2 and x minus 3. Both of them are linear. X minus 2 is a linear polynomial. X minus 3 is also a linear polynomial because the highest power of x is 1. Both are linear. Now when you divide this cubic polynomial by this linear polynomial x minus 2, the remainder is 0 because it's a factor. So when you divide this one by this one, the remainder is 0 because x minus 2 is a factor. But when you divide the same cubic polynomial by x minus 3, the remainder is not 0. It's given that the remainder is r. And you are asked to find the values of m and r. Values of m and r. Right. So see here. Please listen. Do not start writing because I've presented the answer. Please listen to me. So first step is to name the polynomial. Since it's not given a name in the question, we'll just name the polynomial first. So here I've called it f of x. Let f of x be this cubic polynomial. That's the first step. Now take this information. X minus 2 is a factor. So see here, x minus 2 is a factor of f of x. Okay. X minus 2 is a factor of f of x. So now equate this one to 0. X minus 2 is equal to 0. So the value of x is 2. Now if it's a factor, we know the remainder is 0. The remainder is 0. So the value of the polynomial f of x at x is equal to is 0. I told you this place is reserved for the remainder. And this is the value of the polynomial. The value of the polynomial at x is equal to 2 is 0. Because this one is a factor. So the remainder is 0. The value of the polynomial f of x at x is equal to 2 is the remainder. And since x minus 2 is a factor, the remainder is 0. It's not given in the question anywhere, but we know the remainder will be 0. Okay, so this is the equation. Once you construct this equation, it's easy to work ahead. How do you expand f of 2? In f of x, wherever there is x, you're going to use 2. So it'll be 2 cubed m into 2 squared minus 2 plus 6. That's what you see here. That's what you see here. Okay, so this f of 2 is expanded here, and this is equal to 0 as it is. Now, on solving this, you're able to find the value of m. So we found the value of m. Next, we need to find the value of r. So take the other information. Okay. Now, it's given that f of x leaves remainder r when divided by x minus 3. It's given in the question. It's given in the question. Okay, f of x leaves remainder r when divided by x minus 3 is given. So again, equate x minus 3 to 0. So we have x is equal to 3. Now this means the value of the polynomial f of x at x is equal to 3 is the remainder. And what's the remainder? R. So is equal to r. Is equal to r. Equate this linear polynomial to 0 and find the value of x. Now the value of the polynomial f of x at x is equal to 3 is equal to the remainder. And the remainder is r. So f of 3 is equal to r is the equation. F of 3 is equal to r is the equation. So f of 3 means this one. In the polynomial f of x, wherever there is x, use 3. So this is what it is equal to r, is equal to r. Okay. So on working this, you find r is equal to 3. So the value of m is minus 3 and r is 3. So I'll just explain this calculation later. You first try it by yourself, and then we'll just talk about this working. Okay? Yeah. Please write the question and then take down the answer, children. Please write exactly what you see on the screen. Do not write anything on your own. Take it down as you see on your screen.
Finished, ma'am. Finished, ma'am.
Okay, darling. Yeah, please wait.
Finished, ma'am.
Yeah. Done, all of you?
Yes, ma'am.
Yes, miss.
Yes, ma'am.
Very good.
Ma'am,
Yeah?
complete.
Okay. All right. So this f of 3 children, x cubed. So 3 cubed. Then plus m into x squared. Now we know the value of m now. At this point, we know the value of m. So what is m? Minus 3. So minus 3 into x squared. What is x? 3. Right? F of 3. So x is 3. So 3 squared. See, this is x cube. X is 3. So 3 cube plus this is mx squared. What is the value of m? We found here minus 3. So minus 3. X squared. 3 squared. Then minus x. Minus x. That is minus 3 plus 6 is equal to r. So now 3 squared is 9. 9 into minus 3 is minus 27. So 27 minus 27, 0. Yeah, and on working this, we get r is equal to 3. Okay, this is the next one. If r and s are the remainders, when the polynomials p of x and q of x are divided by x plus 1 and x minus 2 respectively, and 2r plus s is equal to 6, find the value of a. So here we are given two polynomials, p of x and q of x, both of which are cubic polynomials. P of x is a cubic polynomial. Q of x is also a cubic polynomial. We have two more linear polynomials given to us. So when P of x, it's given that when P of x is divided by x plus 1, the remainder is r. And when Q of x is divided by x minus 2, the remainder is s. When P of x is divided by x plus 1, the remainder is r. And when Q of x is divided by x minus 2, the remainder is s. There's one more condition or equation given to us. 2 times r, this r, 2 times r plus s is equal to 6. This relationship between r and s is also given to us. Okay, r and s are the remainders, no? So there is some relationship given between r and s. 2r plus s is equal to 6. Now with so much information, find the value of a. I shouldn't say so much. We just have sufficient information to find the value of a. So with all this, find the value of a. So we have p of x, q of x, two cubic polynomials. P of x is divided by x plus 1, and the remainder is r. Q of x is divided by x minus 2, and the remainder is s. And the relationship between r and s is given. 2r plus s is equal to 6. With this, we'll have to find the value of a. Very simple. See here. So I have to repeat because that's what is again here. So p of x leaves remainder r when divided by x plus 1. So equate x plus 1 to 0. We have x is equal to minus 1. Now this means this is p of x, no? So p of minus 1 is the remainder, is equal to the remainder. What is the remainder? R. So this is the equation. The value of the polynomial p of x at x is equal to minus 1 is equal to the remainder. And the remainder is r, is given to us. P of x is the polynomial. And the value of x is minus 1. So the value of the polynomial at x is equal to minus 1, which is p of minus 1, is equal to the remainder, which is r. So p of minus 1 is equal to r is the equation. So now how do you expand P of minus 1? Wherever in P of x, wherever there is x, you should use minus 1. So it will be minus 1 the whole cubed plus 2 into minus 1 the whole square minus 5 into a into minus 1 minus 7. In P of x, here, wherever there is x, use minus 1. Okay, and then is equal to r, is equal to r. So work this. I told you minus 1 the whole square is minus 1 into minus 1, which is plus 1. And minus 1 the whole cube is minus 1 into minus 1 into minus 1, which is minus 1. So be careful while calculating all this. Now, when you work this, you have both the variables a and r. You have both of them a and r. You're not able to find the value of anything, right? So we have this condition here, no? So we'll find the expression for r and we'll find the expression for s. We'll substitute here and with the help of this equation, you will be able to find the value of a. So here we have r is equal to 5a minus 6. See, in the earlier questions, when we solved, we were able to find the value of this m or r, whatever was involved there, whatever variable was involved there. But here you see that in this equation, you have two unknowns a and r, right? In this equation, earlier in the equations, you had only one unknown. So when you solve that equation, you found the value of that unknown. But here you have two unknowns. You can see a and r. So find the expression for r. Find the expression for r. In one equation, if you have two unknowns, you cannot find the value of anything. If there's one equation, there should be only one unknown, like here. See, this is one equation, and there is only one unknown m. So you can solve this equation and find the value of m. But in one equation, if you have two unknowns, like here, this is one equation, but we have two unknowns a and r. You cannot find the value of anything. You will have both a and r. After simplifying, you will have both a and r. So we'll find the expression for r. R is equal to 5a minus 6. Have it as it is. Now, the next thing is, when q of x is divided by x minus 2, the remainder is s. Q of x leaves remainder s when divided by x minus 2. So that means, again, equate, I missed to write that here. Just write it here. X minus 2 is equal to 0. X minus 2 is equal to 0. X is equal to 2. So that means Q of 2 is equal to the remainder. Q of 2 is equal to the remainder. And what is the remainder? S. So now work Q of 2. In Q of x, wherever there is x, use 2. Okay, is equal to S. And when on working this, you get another equation, or you are able to find the expression for S. S is equal to 14 minus 20a. Because in this equation also we have two unknowns, S and A. So you cannot find the value of S or A. Okay. So we have S is equal to 14 minus 20a. So we found the expressions for R and S. Now take up this condition given. 2R plus S is equal to 6 is given to you. So what is the expression for R? 5a minus 6. So instead of R, instead of R, 5a minus 6 plus S. What is S? 14 minus 20a. What is S? 14 minus 20a. So instead of S, 14 minus 20a is equal to 6. So work this and you'll be able to find the value of A. And you see that the value of A is minus 2 by 5. Please work, children. You have to write the question and then work the answer as you see on your screen.
Finished, ma'am.
Finished, ma'am.
All of you completed?
No, ma'am.
Okay.
Yes, ma'am.
Finished, all of you?
Yes, ma'am.
Go, ma'am.
Just a minute, ma'am.
No.
Write only once, not 2 times. How long will you write?
No, now only writing question and answer.
Finished, ma'am.
Yeah. Okay, so after this, you will have to take a screenshot, children, if you have not completed. Take a screenshot if you have not completed. Do it later. We have to go to the next one.
Ma'am, taken.
Yeah. No, but that's not an option. Don't take a screenshot because you have not completed. You can just leave some space and complete it later using the screenshot. But don't take screenshots for every other answer and, sit idle in the class, children. Please try to finish it in the class. Next one. When polynomials f of x and g of x are divided by x minus 3, the remainder in each case remains the same. Find the value of p. Okay. So f of x is a cubic polynomial. G of x is also a cubic polynomial. You can see this unknown p here also. In both f of x and g of x, you can see this unknown p. You have to find the value of p. Now it's given that when both the polynomials f of x and g of x, when they are divided by x minus 3, you can see that in every question, the divisor is linear. The divisor is linear. Only then you can proceed the way we're doing. If it's not linear, we'll see how to work that. I'll tell you when we come across a situation like that, a question like that. So you can see here that the dividend polynomials can be of any degree. F of x and g of x are the dividend polynomials. They can be of any degree. So here you can see both of them are cubic polynomials. But the divisor polynomial has to be linear. You can see it's linear. Okay, so when f of x and g of x are divided by x minus 3, the remainder is the same in each case. Find the value of p. So x minus 3 is equal to 0. X is equal to 3. Now, f of x, right? So when you find f of 3, you will be able to find the remainder when f of x is divided by x minus 3. The other dividend polynomial is g of x. When you find g of 3, the value of the polynomial at x is equal to 3, when you find g of 3, you will be able to find the remainder when g of x is divided by x minus 3. Now what is given? This remainder and this remainder both are the same, which means f of 3 is equal to g of 3 is the equation. X minus 3 is the divisor polynomial equated to 0. So the value of x is 3. Now we have two dividends, f of x and g of x. Now to find the remainder when f of x is divided by x minus 3, we have to find f of 3. X is 3, right? This is the divisor. So x is 3. So when you find f of 3, you will be able to find the remainder when f of x is divided by x minus 3. Similarly, when you find g of 3, because both are divided by x minus 3, both f of x and g of x are divided by x minus 3. X minus 3 is the divisor for both the dividends. So when you find g of 3, it will give you the remainder when g of x is divided by x minus 3. Now what is given? The remainder is the same in both the case, which means this remainder f of 3 is equal to this remainder g of 3. See, when you find f of 3, you will get the remainder. When you find g of 3, you will get the remainder. These two remainders are the same. So this is the equation. F of 3 is equal to g of 3 is the equation. F of 3 is equal to g of 3. See here? So how do you work f of 3? Here in f of x, wherever there's x, 3. And g of 3, how do you work that? Here in g of x, wherever there is x, 3. So when you solve this, you'll be able to find the value of p. And p is minus 1. Right down, children? The solving part I'm not explaining. This, I'm sure you can help yourself. This is the, the core idea. This is the core equation. If you should be able to write this. If you can write this, then all this is very easy. Please write the question and complete the answer.
Finished, ma'am.
Completed.
Okay, class, use the emoji, raise your hand. Use the raise hand option and raise your hand, children. Shreya, Yarni, Nuved, Haridarshan. I forgot who's in. Surya, Lakshana, Anika, Harsha, Sanjay. Oh, Rahul, Anita, and Gayatri. Gayatri, you've joined from 2 different devices? Okay, no. Okay, good children, fine. All of you finished this one?
No, ma'am, 1 minute. Yes, ma'am.
Okay. Yeah. Done?
Yes.
Yes. Yeah,
Yes, ma'am.
good. Look at this question. If the polynomial f of x equals x to the power 4, and we see the highest power is 4, so biquadratic, x power 4 minus 2x cubed plus 3x square minus 9x plus 3a minus 7. So when f of x is divided by x plus 1, you can see x plus 1 is linear. The dividend polynomial is of degree 4, biquadratic. The divisor polynomial is linear, degree 1, linear, is divided by x plus 1. Okay, when divided by x plus 1, leaves the remainder 20. Find a. Also find the remainder when f of x is divided by x plus 2. So we have f of x dividend, we have x plus 1 divisor. When you divide f of x by x plus 1, the remainder is 20. So how do you write this as an equation? Equate the divisor to 0. We get x is equal to minus 1. And f of x is the dividend. When x is minus 1, so f of minus 1, you will get the remainder. When you find f of minus 1, when you find the value of the dividend polynomial at x is equal to minus 1, you will get the remainder. You should write the remainder here. And the remainder is given to be 20. So this is the equation. F of minus 1 is equal to 20 is the equation. So when you work this, you will be able to get the value of a. Find the value of a. You can solve and find the value of a. Once you find the value of a, use that in the, now supposing a is some 3, okay? So f of x is equal to x to the power 4 minus 2x cubed plus 3x square minus 9x plus, if supposing you got a is 3, so it will be 3 into 3. A is 3, no? So 3 into 3, 9. 9 minus 7, 2. So plus 2. If a is 3, 3 into 3, 9. 9 minus 7, 2. So this is the polynomial. Now it's complete. You can see x power 4, x cubed, x squared, x in the constant. There is no other unknown other than x, the variable. So now the polynomial is complete. Earlier it was not complete because there was a. Other than the variable, there was another unknown a. So now it's complete. Okay. Now you should find the remainder when f of x is divided by x plus 2. So x plus 2 is equal to 0. X is equal to minus 2. And to find the remainder, you just have to find f of minus 2. That's all. When you find f of minus 2, you will get the remainder. You will get the remainder. Now you don't know the remainder. When you find this value, you will get the remainder. You should work f of minus 2. Please take the help of the slide and finish the answer. If you have any questions, I can help you at the end of it. Yeah. Write down the question and complete the answer.
Finished, ma'am.
Okay.
Finished, ma'am.
All right. Finished, all of you?
Yes, ma'am.
No, ma'am.
Done, all of you?
Yes, miss.
Okay.
Yes, ma'am.
Ma'am.
Very good.
No, ma'am. Last point.
Okay.
Just a week.
Sure. Yeah. So it's given f of x leaves remainder 20 when divided by x plus 1. So now you understand x plus 1 is equal to 0, x is equal to minus 1. That's why we say f of minus 1 is equal to 20. X plus 1 is equal to 0, x is equal to minus 1 on solving this. Okay. So it means f of minus 1. You can include this step, children. I'll also include this. So f of minus 1 is equal to 20. This is the remainder. So when you work this, you're able to find the value of a. And as I told you, in the polynomial f of x, here for a, use 4. You found the value, right? So use 4. So this is 3 4s are 12, 12 minus 7 plus 5. So this is the polynomial.
Ma'am.
Yes?
Ma'am, completed.
Okay. So this is the polynomial. Now you should find the remainder when you divide f of x by x plus 2. So again, x plus 2 is 0, x is equal to minus 2. So you have to find the value of the polynomial at x is equal to minus 2. When you find the value of the polynomial, that will be the remainder. So find the value of the polynomial at x is equal to minus 2. So minus 2 to the power 4, minus 2 into minus 2 the whole cube, plus 3 into minus 2 the whole square, minus 9 into minus 2 plus 5. So the value is 67. So when you divide f of x by x plus 2, the remainder will be 67. When you divide this f of x, you know the long division, right? So when you divide this one by x plus 2, okay, you will see that the remainder is 67. We have found the remainder using the remainder theorem without actually performing the long division. Yeah, please ask me. See, apart from what I've explained, you might have some question in your mind that you should ask me. You might feel that I have not, answered something or answered the question which you have in your mind in my explanation. So you should ask me. Any clarifications? Any part of the answer I've not explained clearly, please ask me. Okay. So I assume it's good for all of you. Very nice. Okay. Now, the difficulty is, when some part of the syllabus has been deleted some 3 years ago, no? From 2021, some part of your syllabus has been deleted. So now what you are having is the rationalized NCRT maths textbook. In spite of that, some schools do include the questions from the portions which have been deleted. So for that reason, see, mine is a complete classroom in the sense the promise I give parents is when I complete a chapter here, there can be no question, outside this that any school can ask in their test or exams. All right. So even if some part of the syllabus is deleted, I see questions being asked, from those portions, not in all the schools, some 1 or 2 schools. For which reason, see this question actually, even for 10th standard, it says it's deleted. We have similar questions in 10th standard, deleted, but then I see it happening in some question papers. And see, knowledge is not going to be a waste, If not for 9th, 10th, this will be useful for 11th, 12th, and even beyond. So just spend 5 minutes to practice this. You're not going to lose anything. Then it's left to you. If you can check with your teacher, if this kind of a question will not be asked, you can. But for every other chapter, you cannot go to your teacher and ask her if, such a question you will ask or not ask. You don't have that. I don't think that space to ask your teacher, right? So I leave it to you. So this one, if it is for knowledge, then please practice and remember this. It's a very simple thing. What must be added to f of x so that the resulting polynomial is divisible by g of x? Okay, what should be added to f of x so that the resulting polynomial is divisible by g of x? Now see here. So say like we have 29. And when you divide 29 by 5, 5 5s are 25, 4 is a remainder. Now, using the remainder, we'll answer 2 questions. Using the remainder, we'll answer 2 questions. Now, what is the least number to be subtracted from 29 so that it is exactly divisible by 5? Using the remainder, you should answer. What is the least number that is to be subtracted from 29 so that it is exactly divisible by 5? Should answer this question using the remainder. So the remainder has to be subtracted. So 29 minus 4 is 25. If you subtract the remainder, then the resultant number is divisible by 5. Now, the same question, if it is added, what is the number to be added? You should answer the question using the remainder. The negative of the remainder should be added. What is the remainder? 4. What's the negative of the remainder? Minus 4. The negative of the remainder should be added. So 29 to 29, what should you add? You should add the negative of the remainder. Okay, which gives you 25. And now this resultant number is exactly divisible by 5. "29 is not exactly divisible by 5. So we have 2 questions here. What is the number to be subtracted? You should answer this question using the remainder. Using 4, you should answer the question. You have no other option. Only using 4, you have to answer this question. So if the question is, what is the number to be subtracted? What is the least number to be subtracted from 29 so that the resultant number, that new number, is divisible by 5? So then you should say, what's the remainder? 4. So 4 should be subtracted. So 29 minus 4, the remainder. The answer is 25. And now 25 is exactly divisible by 5. Same question, what is the number to be added? 29 plus, add the negative of the remainder. What is the remainder? 4. Add the negative of the remainder. Minus 4. Add minus 4. Subtract the remainder itself. What is to be subtracted? Remainder. Minus the remainder. What is to be added? Add the negative of the remainder. So what is 29 plus negative of the remainder minus 4? 25. And now 25 is exactly divisible by 5. Apply the same thing here. Perform the long division. If the question is what is to be subtracted, whatever is the remainder you get is to be subtracted. What is the number to be added? Sorry, what is the expression to be added? The negative of the remainder should be added. What is to be subtracted? The remainder, whatever is the remainder, must be subtracted. What is to be added? The negative of the remainder is to be added. And long division we saw in the last class. Try to do it by yourself. I'll present the answer. So you can see here, the remainder we get is minus 61x plus 65. So what is to be added? The negative of the remainder minus of the remainder. That is minus into minus plus 61x and minus into plus minus 65. So this is to be added to f of x so that it is divisible by g of x. Yeah. Please do this division, children. I think this class when we did division, some of you were absent. Let's just do it again. Don't write now. We just, yeah. Yeah, I'll just explain this. Last class or the class before that, we had taken up one long division procedure and we understood, but I'm just
Friday's class.
Friday's class.
Friday's class. Yes,
Okay, yeah. Okay, I just assume that I'll just do it again so that if you'd missed that class or something, it will be useful for you. So we'll have to divide. See, the first thing is you need to disable your mic, children. The first thing is to arrange the terms of the dividend and the divisor in the decreasing order of the powers of x. X is the variable. X is the variable. In both the dividend and the divisor, arrange the terms in the decreasing order of the powers of x. So x power 4, x cubed, x squared, x constant, already arranged. In the divisor also, x squared, x constant. Okay, already arranged. So we don't have to do that. It's already done in the question. Okay. Now, how do we start the division process? 4x to the power 4 divided by x squared. Divide the first term of the dividend by the first term of the divisor. And what we get is 4x squared. And that's the first term in the quotient. Now we will have to multiply 4x squared with x squared plus 2x minus 3, the divisor. Multiply the term which you write in the quotient with the divisor. So what do you get? 4x squared into x squared, 4x to the power 4. 4x squared into 2x, 8x cubed plus 8x cubed. Then 4x squared into minus 3, minus 12x squared. Subtract. So which means we'll have to change the signs. Plus becomes minus, plus minus, minus plus. Change the signs of all the terms in the second row, the bottom row. Now this is 0. Plus 4x to the power 4 minus 4x to the power 4, 0. Plus 2x cubed minus 8x cubed. Take the new sign. Forget the old sign. Take the new sign. Plus 2x cubed minus 8x cubed minus 6x cubed. Minus 2x squared plus 12x squared plus 10x squared. Bring the remaining terms down. Whatever is not used. 1, 2, 3 terms are used. This plus x minus 1 comes down. Repeat. This is called the new dividend. This is the new dividend. So to get the second term in the quotient, repeat the same process. Divide the first term of the new dividend by the first term of the divisor. And that gives us minus 6x. That's the second term in the quotient, minus 6x. Now multiply minus 6x with all the terms in the divisor, x squared plus 2x minus 3. So minus 6x into x squared minus 6x cubed minus 6x into plus 2x. So minus into plus minus 6 into 2, 12, x into x, x squared minus 12x squared. And finally, minus 6x into minus 3. Minus into minus plus, 6 3s are 18x. Change the signs of all the terms in the bottom row. Write the opposite sign. Minus becomes plus, plus becomes minus. Cancels. Plus 10x squared plus 12x squared plus 22x squared plus x minus 18x minus 17x minus 1. This term minus 1 is still not used. Bring it down. This is the new dividend. This one is a new dividend. Divide the first term of the new dividend with the first term of the divisor. So 22x squared divided by x squared, which is 22. 22 means plus 22. Now multiply 22 with the divisor, with every term of the divisor. So 22 into x squared is 22x squared. 22 into plus 2x plus 44x. 22 into minus 3 minus 66. Change the signs of all the terms in the bottom row. Cancels. Minus 44 minus 17 is minus 63, right? 61, sorry, minus 61x. And plus 66 minus 1 plus 65. Now, how do we know that the division has come to an end? When the degree of the remainder goes less than the degree of the divisor, you need to stop the division process. Exactly like we do with the numerical situation, like when you divide like some number by 7. Now, and the remainder says 4. You stop the division. Why? Because this number has gone less than 7. If it was 7 here, you will say 7 ones are 7 and 0. So when the remainder is equal to the divisor, you will continue the division process. When will you stop the division process? When the value of the remainder goes less than the value of the divisor. When it's equal also, you will continue the division. Like as I just told you, when you're dividing by 7 and after a series of steps, you get 7. You will not stop the division. You will say 7 ones are 7 and 0. So when the remainder is equal to the divisor, you will continue the division. Then when will you stop? You will stop when the remainder goes less than the divisor. When this is like 4. Okay, so you will stop the division there. Remainder is 4. It's less than 7. So you stop the division there. In the same way here, when the degree of the remainder is equal to the degree of the divisor, you should continue the division. Children, disable your mic. I don't know who it is. Please disable your mic. All of you check your mic, disable it. Yeah. When the degree of the remainder is equal to the degree of the divisor, continue the division process. When the degree of the remainder goes less than the degree of the divisor, the division comes to an end. And that's what has happened here. What's the degree of the remainder? 1. What's the degree of the divisor? 2. You should stop. The degree of the remainder, x power 1. The degree of the remainder is 1. The degree of the divisor is 2. The degree of the remainder has gone less than the degree of the divisor. So we stop the division process. See, you might say, ma'am, all the terms are exhausted. Why will I continue? Everything we have used. We have used all the terms, so we have to stop. That's correct. But you need to know this theory also. You also need to know this theory, which is why I just mentioned that. If you feel, yeah, we've used all the terms, now what to divide? Yes, you're right. We've used up all the terms, so there's nothing to divide. But you should also know this fact about the relation between the remainder and the degree of the remainder and the degree of the divisor. Okay. Yeah, please work this, children. Here I don't have the working, this one which I've shown here. So I'm not presenting this slide. I'll present this slide. After doing the division, you'll have to write this line in the end. This line is to be added. I'll show the slide later. Now use this slide and complete the answer, the division. I'll come back in 5 minutes, finish it.
Ma'am, completed.
Completed, ma'am.
Okay, yeah, please wait for your friends to complete.
Completed, ma'am.
Finished, ma'am.
Yeah,
Complete, ma'am.
yeah. See, you should have taken the working also so that when you revise, it will be useful for you to recall the division process. This division is of 8th standard, but again, it's division of polynomials. Dividing an algebraic expression by a monomial, binomial was deleted for 8th standard. So I don't know if you've learned it in standard 8. Somebody's mic is enabled. Please disable your mic. Okay. Yeah, please make a note of the last line. That's the answer. So what is to be added? The negative of the remainder is to be added. Done, children?
Yes,
No, ma'am.
miss. Yes,
Okay.
miss.
Okay. This question is very similar to the second one, I think. 1 second. Not the second one. Yeah, the third one. The question which I'm presenting now is similar to question number 3. So please write this question. Take the help of that answer and complete this by yourself and tell me the value of K. Comfortable working, children? Able to do it?
Yes, miss.
No, ma'am.
No?
Yes, ma'am.
Okay. We'll
Confusing.
do it together. Don't worry.
No, I can't understand it.
Yeah,
It's
yeah.
too confusing.
Sanjay, yeah? Who's that?
Ma'am, Rahul.
Rahul. Okay. 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 So what? Can you tell me the expression for A? What's the expression for A?
A is equal to P 2x cube plus K x square
What's the expression for A?
Ma'am, A is equal to 2x cube plus K x
No, no,
square.
no. Oh, you're telling reading on all the steps. Okay, A is equal to 2x cube plus kx squared.
Minus 3x plus 5. That's all.
Okay. So P of x is divided by G of x, right? When P of x is a cubic polynomial, G of x is a linear polynomial. When P of x is divided by G of x, the remainder is A. When Q of x is divided by G of x, the remainder is B. Is that understood, children? When P of x is divided by G of x, the remainder is A. And when Q of x is divided by G of x, the remainder is B. So what is G of x? X minus 2, equated to 0. So we have x is equal to 2. X is 2. So find the value of the dividend polynomial at x is equal to 2. This is the dividend polynomial. Find the value of this polynomial at x is equal to 2. So P of 2. When you find P of 2, you will get the remainder. And what's the remainder? A. So this is the equation. P of 2 is equal to A is the equation. The second one also, the divisor is x minus 2. So equated to 0. Find the value of x. X is 2. Now find the value of the dividend polynomial at x is equal to 2. This is the dividend polynomial. The value of the dividend polynomial at x is equal to 2 is q of 2. And when you work q of 2, what will you get? You'll get the remainder. And what's the remainder? It's b. So b is equal to q of 2. A is equal to p of 2. B is equal. See, a and b are the remainders. A and b are the remainders. And what are the expressions for the remainders? P of 2 and q of 2. Because the divisor is x minus 2. So x minus 2 is 0, x is 2. So when you find P of 2, you will get the remainder. When you find Q of 2, you will get the remainder. So P of 2 and Q of 2 are the remainders. So P of 2 is equal to A, Q of 2 is equal to B. They are the equations. They are the equations. So how do we find P of 2? In P of x, wherever there is x, use 2. So you can see here, is equal to A. So this is the expression for A. Similarly, in Q of 2, sorry, not in Q of 2. Similarly, for Q of 2, to work Q of 2, in Q of x, wherever there is x, use 2 is equal to B. So the expression for B is 14 plus K. So A is equal to 4K plus 15. See, because in this equation, you have K unknown, A also unknown. We have two unknowns, so you cannot find the value of any of them, because one equation, if it has only one unknown, you can find the value of that unknown. One equation, two unknowns, you cannot find the value of anything. So you have k and a, two unknowns. So a is equal to 4k plus 15. This is the expression for a. Similarly, find the expression for b, 14 plus k. Now use these two expressions in this condition. A minus b is equal to 0. What is a? 4k plus 15. What's b? 14 plus k. A minus b. So this is a minus, this is b, is equal to 0. A minus b is equal to 0. This is a, this is b. A minus b is equal to 0. So open the bracket, you will get minus 14 minus k. Minus 14 minus k. So on solving this, the value of k is minus 1 by 3. Minus 1 by 3. See, you might have tried by yourself and may have completed it, or may have, like accomplished half of the answer. But if your steps are not like this, please take down the answer from your screen. Please take down the answer from your screen. Sorry, please take down the answer as you see on your screen, children. Yes, Rahul and others who were not able to do it, please ask me if you have any questions.
I made a mistake in the first case.
Oh,
So I'm like confused.
okay, okay. P of 2 we get because x minus 2 is equal to 0, x is equal to 2. That's how we get 2 here. Finish the answer and let me know.
I'm completed.
Finished, miss. Finished, ma'am.
All right.
Completed, ma'am.
Very good. Okay. So this part you'll have to be careful. A minus B. This is A. See, don't write like this. This is A. A you can write like this, but minus B, if you write minus 14 plus K like this, you're wrong. Minus B. This is B. Minus B. So B, because it has more than one term, you should enclose it in a bracket. So next step, it will be minus 14, minus into plus minus K. Okay. If x minus 7 and x minus 4 are factors of f of x equals px cube plus qx squared minus 5x plus 84, find the values of p and q. So f of x is a cubic polynomial. F of x is the dividend polynomial. It's a cubic polynomial. The variable involved is x. The other unknowns in the polynomial are p and q. And we have to find the values of p and q. Other than x, in the polynomial f of x, other than the variable x, we have two unknowns, p and q. So we have to find the values of p and q. Okay, so what information is given to us? X minus 7 and x minus 4 are factors. So that means when you divide f of x by x minus 7, the remainder is 0 because x minus 7 is a factor of f of x. Similarly, x minus 4 is a factor of f of x. So when you divide f of x by x minus 4, the remainder is 0. So f of x is the dividend polynomial. Okay, x minus 7 is the divisor polynomial equated to 0. So you have x is 7. So how do you find the remainder? You must find f of 7. F of 7 is a remainder. But what's the remainder? 0. Because you're dividing by the factor f x minus 7. Similarly, x minus 4 is equal to 0. X is equal to 4. So how do you find the remainder? F of 4 will give you the remainder. F of the dividend is the same. Divisors are different. So f of 4 will give you the remainder. And what's the remainder? I told you this place is reserved for the remainder. What's the remainder? 0. Why? Because both of them are factors. So the remainder will be 0. So these are the two equations. F of 7 is equal to 0 and f of 4 is equal to 0. These are the two equations. So see here. F of 7 is equal to 0. F of 4 is equal to 0. So f of 7 meaning in f of x, wherever there is x, you must use 7. And f of 4 means in f of x, wherever there is x, you should use 4. So this is what you get after simplifying. 343p plus 49q is equal to, 343p plus 49q plus 49 is equal to 0. Okay. Now you should know that 7 into 7 is 49. 49 into 7 is 343. 7 into 7, 49. 49 into 7 is 343. So you can divide 343 by 7. You can also divide 49 by 7, 49 by 7, and 0 by 7. So you can divide the equation throughout by 7. You can, 49 itself. I'm sorry. This is 49, this is 49. This is also divisible by 49 because 7 times. 7 into 7 is 49 into 7. So 49 into 7 is 343, children. 343. All right. So you can divide this equation throughout by 49. Okay. So 343 by 49, 49 by 49, 49 by 49, and 0 by 49. Dividing the equation throughout by 49 meaning dividing every term of the left hand side by 49 and every term of the right hand side by 49. So here on the right hand side, we have only 0. So 0 by 49 is 0. 0 by 49 is 0. 49 by 49, 1. 49 Q by 49 is Q. And this one, 343 P by 49. 49 ones are 49 sevens. So 7P. 7P. We're just doing this, children. We're just doing this. Every term is divided by 49. Write the answer here. So you get a new simpler equation. You get a new simpler equation. So you get 7P plus Q plus 1 is equal to 0. Have P and Q on one side and take the constant to the other side. Have P and Q on one side, take the constant plus 1 to the other side. So this is the equation you get. 7P plus Q is equal to -1. Now dealing with this in the same way, you get this equation and you can see 64, 16, 64. All these three numbers are divisible by 16. So divide by 16 throughout. Dividing by 16 throughout. 16 ones are 16 fours are. So 4P. 16 and 16 cancel. So plus Q. 16 ones are 16 fours are. So plus 4. 0 by 16 is 0. Now when you bring the constant to the other side, plus 4 becomes -4. So the equation is 4P plus Q is equal to -4. Now write the equations one below the other. Write the equations one below the other. This is the equation 1, this is the equation 2. Write them one below the other. Now you can see Q and Q here. But plus Q is plus 2Q. Plus Q is plus 2Q. So change the signs throughout in the second equation. The second equation, change the signs throughout. Plus 4P minus 4P, plus Q, minus 4 plus 4. All right. Change the signs throughout in the second equation. Now Q minus Q. Once you change the signs, forget the old signs. Consider only the new signs. Forget the old signs. Excuse me. So Q minus Q, 0. Q minus Q, 0. 7P minus 4P, 3P. Minus 1 plus 4. New sign, minus 1 plus 4 is 3. So P is equal to 1. P is equal to 3 by 3, which is 1. 3P is equal to 3. So P is equal to 3 by 3. P is equal to 1. So we found the value of P. We found the value of P. Now how do you find the value of Q? Substitute P is equal to -1 in this equation or in this equation. See, this equation is P and Q, no? You know now P is 1. P is 1. So 7 into 1, 7. So when you take that 7 to the other side, 7 into 1, 7. When you take 7 to the other side, -7. So you will get Q is equal to -8. Q is equal to -8. Or you can put the value of P here also. What's the value of P? 1. So what is 4 into 1? 4. So when you bring that 4 to the other side, plus 4 becomes -4. So Q is equal to -8. So you can substitute. See, these two equations have two unknowns, P and Q. Now that you found the value of P, if you put the value of P here, you can find the value of Q. Or if you put the value of P here, you can find the value of Q. So that's what it is. Substituting P is equal to 1 in equation 1. Any equation you can substitute in 1 or in 2. Any equation. I have put it in equation 1. So we get, yeah, you can see here, 7 into 1 plus Q is equal to -1. So on solving this, you find Q is equal to -8. So like this, we find the values of P and Q. So this is a new situation in the sense, we get two equations in two unknowns, P and Q. And we'll have to solve them. This is called the elimination method because we eliminate the unknown Q. All right, so we eliminate this and we find the value of P. And then by substituting, we find the value of Q. It's called solving the equations simultaneously. Simultaneous equations. Simultaneous equations. Writing the equations one below the other and solving them simultaneously. You're working with two equations simultaneously, right? At the same time, you're working with two equations. So simultaneous equations. So in this method, we get rid of one of the unknowns. Q is eliminated. So you're able to find P. Once you find P, you substitute that value in one of the two equations and find the value of the other unknown. Yeah. Write down this answer, children. Write the question and take down the answer.
Finished, ma'am.
Finished, ma'am.
Completed, ma'am.
Anyone still working?
Completed, ma'am.
Okay. Done, children?
Yes,
Yes,
miss.
ma'am.
Okay. So this one is very similar to the earlier one. See here. If x plus 2 and x minus 1 are factors of p of x equals x cubed plus 10x squared plus mx plus n, find the values of m and n. So here also you have one dividend polynomial, here like here. Here also it's a cubic polynomial. Here too it's a cubic polynomial. There are two factors, here x minus 7 and x minus 4. Here x plus 2 and x minus 1. In this question, we have to find the values of m and n. Here the unknowns were p and q, so find the values of p and q. Exactly the same situation. So this will be your homework question. Apart from this, I'll be sending you some more questions which you have to practice. Take down this question, children. All of you must be able to get the answer for this one. Take down the question. Done?
No, ma'am.
Okay.
Done, ma'am.
Yeah.
Done, ma'am.
Nice. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you, ma'am. Thank you.
Thank you, ma'am.
Thank you,
Thank you,
children.
ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Thank you. Good night.
Good night.